All right, this is Josh Mandel with a quick demo of a tool that I've been working on for generating some synthetic FHIR data around specific encounters. And I guess I'll just try to give you a quick sense of how it works. And so let's say we've got a quick clinical sketch, 62-year-old female with new angina. She is a pirate and talks like a pirate. And I'm going to go ahead and create a synthesis job. I'll talk to you a little bit about what's happening in the background here, but we are calling a whole bunch of LLMs to do a whole bunch of things, and we can watch our token count tick up here as we can go through several of these calls. But the first thing that happens is we ask a language model to generate an outline for this note. And we're going to start by writing a free text note, and it's going to have these sections that the outline generation model has created. So this is a pretty simple prompt flow at the start, where we just ask a language model to list the sections, and then we're going to go ahead and synthesize and review those sections one by one. And if you drill in here, you can see the details of the prompt. It included my sketch and just guidance about how to output sections and what a section should look like. But it doesn't specify, what those sections should be, other than kind of like looking for a logical order of 4 to 8 sections. It relies on the language model's underlying knowledge about kind of how to do this appropriately. So as I've been touring that initial prompt, you can see we've got section briefs that have been created for these 8 sections, chief complaint up through an assessment and plan. And that brief is just kind of a short paragraph saying what the section ought to talk about. And then we generate a draft for each of those sections. So here's a draft for the past medical history. And that draft gets critiqued. And in this case, the critic is reasonably happy. The draft does a solid job weaving the pirate voice into the medication plan while staying clinically accurate. And we get a score of 85%. That's good enough to pass our approval threshold. So we're going to approve that. And so on and so forth. We're going to draft each section of the note. Then we get a draft of the whole note by stitching all those sections together. And we get a critique of our whole note, which says that it's well structured, 86%. So still not like super wonderful, but good enough to keep going. And so we get a release candidate of our text note. And so now this is a single note, which has these 8 sections, pretty short. This is, similar to what you might find in a real clinical note in terms of the content that you see on the screen here. And if we drill into it, they've got some nice color here with the pirate language. Describe the discomfort as a pressure-like weight of a cannonball that began 3 days ago while climbing the ship's rigging. So that's our release candidate for a free text note. And then once it's constructed this release candidate by stitching all those sections together, the prompt flow continues by asking a language model to go ahead and scaffold that into a FHIR composition resource. So in this case, it's going to be a consultation note. And this composition resource is going to look a little bit funny. It has displays for most of the references, and these displays are not going to land in the final document that we produce, but they're placeholder values that are going to help drive further downstream synthesis of these referenced resources. So we see things like a 62-year-old female pirate with hypertension, hyperlipidemia, and chest discomfort. These are just helping to guide the synthesis of each of these. And you can see we use the sections from our original note. We splice in the narrative from those sections, and we think about what entries we might want to point to. We haven't written these yet, but we might say the past medical history is going to have hypertension, hyperlipidemia, couple procedures, hysterectomy, cholecystectomy, and so forth. And that scaffold with this list of entries is going to drive the next process, the next part of our synthesis process, where we are going to generate all the conditions and medications and observations and so on that we envisioned in that scaffold. And the interesting thing here is we can ask a language model to generate those resources, but it's typically going to make quite a few errors. So we have a refinement pipeline where we prompt the language model. First we ask it to generate a cholecystectomy procedure, and I can show you what that original generated resource looks like before we start refining it. So that's going to look like this. It looks like very plausible FHIR JSON. Surgical procedure, cholecystectomy, happened on a certain date, fair and good. But if we look at this prompt that we use in the refinement pipeline, you're going to see we've done a couple things. We have provided the current resource and also provided a list of codings that looked wrong and any validation errors. So we actually produced valid FHIR in terms of the structure, but we didn't have a good coding for surgical procedure or a good coding for cholecystectomy. There, of course, is going to be a SNOMED code for it, but the language model does not know these things by heart. So we allow the language model to go through a couple of loops where it can first say, I want to search for cholecystectomy in a SNOMED terminology server, and then we'll prompt it with all the results that you get when you search a SNOMED terminology server with cholecystectomy. And there's a whole bunch, some procedure codes, various different flavors, partial cholecystectomy, and so on. And we just give it all those codes and ask it what to do next. And what it chooses to do next is we're gonna now look for the term surgical procedure. So it really should have taken the opportunity to use that code. It could have applied a patch, but instead it's decided to go off and do something slightly different. But eventually it does decide to assign this cholecystectomy code from SNOMED into our resource. And presumably it finds the right procedure code as well. And at the end, we've got a validation that passes. So all the codes are valid and the resource is structurally valid. So we go through a whole bunch of generation and refinement procedures on each of these resources, and then eventually we're going to get to the end. And now here we hit an error. I've been using OpenRouter here. It looks like our GPT OSS model was down for a moment, and this would have been retried a few times, and then eventually it'll halt the pipeline if it can't recover. But I can try pressing the resume button and we'll replay our progress through this pipeline. We don't have to go and make all these language model calls and validation calls again. We've saved all the interim results, and the workflow engine that this program is using, it's a pretty simple JavaScript engine that just stores the results in an indexed DB in the browser and makes them available for playback later. So even though OpenRouter was down for a little bit, we're able to recover. In this case, I manually clicked the recover button, but of course we could have some more sophisticated strategies that would do things like pausing for longer if things weren't working. So now we've generated almost all the resources we need. We finally generated a document bundle representing the entire note, which is going to have all the entries inside of it. And we've got a validation report, which in this case is still showing a few errors. So it's not a perfect bundle, but it's pretty close. And in this case, it looks like our errors were with the section XHTMLs, the narrative rendering of these sections. So we can take a look at this, but it looks like the way that I'm generating the XHTML from these markdowns still has a few errors. But that's pretty good. That implies that the codings are valid and the actual resource content is valid throughout this bundle. So that's a quick view of what you can do with this kind of synthetic generation. And it's a combination of rote prompt flows, so just following a sequence of steps that's going to be the same every time, plus some agentic loops embedded deep into those prompt flows so that we can do things like refining the resource step by step while giving the language model access to some tools and letting it decide what order to tackle the problems in and how to address them based on vocabulary searches and JSON patches to edit these resources bit by bit. So that's a quick tour. And if you want to play with this, you still need to run a local copy of this validator server, even though the tool itself is hosted at joshuamandel.com/kiln. It's actually connecting locally to port 5173 on my local machine. And there's an open source repo that manages all this at github.com/jmandel/kiln if you want to check out how the code works, or if you want to try running this on your own. All the content that you need is right there and ready to go. And that is all for today.